my name is Joshua Green, and this is my Physics 2212 Lab 3 report on circuits and capacitors. The purpose of this lab revolved around understanding and analyzing the behavior of DC, direct current, and RC, resistor capacitor, circuits through the principles of energy conservation, or the loop rule, and current conservation, or the charge conservation. These principles allowed us to predict the behavior of circuits containing resistors in series and parallel circuits, use multimeters to measure actual values of conventional circuits and the potential differences in the circuits, and finally, examine the behavior of resistors and capacitors. A brief preview of the results include the light bulb getting bright, then dimming in a fast manner, the resistor of the series circuits having the predicted values previously calculated, and the RC circuit having a negative linear plot for the current. Some assumptions made before starting the experiment was that the resistance of wires in ammeter is negligible. Additionally, for the entirety of the experiment, the system is the circuit and the surroundings are everything else. Using the PHYS model, I was able to observe the combination of different capacitors and resistors. Some important concepts that are utilized in this experiment include the following. Ohm's law relates to voltage, current, and resistance in a circuit, which is crucial for predicting and measuring the behavior of circuits containing resistors. The loop rule states that the sum of potential differences around any closed loop in a circuit must be zero. The node rule states that the sum of the potential differences around any closed loop in a circuit must be zero. The node rule states that the total current entering a junction must be equal to the total current leaving the junction. The potential difference helps relate the differences across the capacitor to the charge stored on it, the area of the plates, and the permittivity of the free space. The capacitance formula also helps relate physical characteristics of the capacitor. And finally, calculating RC is crucial for further predicting circuit behavior. For part 1 of the experiment, I predicted that I1 would be equal to IT based on the node rule, and the calculations are provided to validate this prediction. Stating that I would equal 0.02A. I constructed the circuit by having two ammeters to two 1.5 voltage batteries and two resistors with a resistance of 47 and 100 ohms to create the following model, as seen here. From there, I recorded the current flowing through the ammeters, then reversed the ammeter and recorded once more. I then replaced one ammeter with a voltmeter and recorded the current on the remaining ammeter. Finally, the voltmeter was disconnected and the potential difference were taken from around the circuit. The results were that the predicted and measured current matched the reversed ammeter current read at negative 0.02 A. Overall, the values matched. For part 2 of the experiment, the bottom ammeter is replaced with a voltmeter, and to create an open circuit, the predicted potential difference is 3 volts and the current is 0. Results were found that the observed values matched with the predicted values once again, as similarly seen in part 1. To continue, a visual representation for this part of the experiment is seen right here, to which I measured the voltage difference at given locations as seen in this upper picture, and recorded the values to calculate delta V net, which was calculated to be 0, which aligns with the loop rule. From A to B, the voltage was seen at 3, from B to C, it was at 0, from C to D, it was negative 0.96, from D to E, it was 0, and from E to F, it was negative 2.04 volts, and the remaining were 0. For part 3, a similar simulation was made based on the previous simulations, except for the ammeter being in parallel with the 100 ohms resistor. The measured current was then increased to 0.06 A, and the observed results were that there was an overall increase at the junction. Here are the remaining calculations. Here are the remaining calculations used to calculate the 47 ohms resistor, 100 ohms resistor, wire, and ammeter. For the last part of the experiment, the RC circuit, the procedure consisted of connecting a 9-volt battery to a 10 or 20 ohms bulb and a 20 mF capacitor. Results were seen from both bulbs that the bulb would get brighter then dim until the light completely dissipates. And once the same observation was made when the battery was disconnected, and here are the times that it took to charge and discharge for both the 10 and 20 ohms bulb respectively. For the time-dependent model I took various time points from 0 to 20 and created a graph which displayed a negative linear line, and the experimental RC value was calculated to be around 6 seconds, which further aligned with the calculated RC value of 6 seconds. Um, if this experiment were to have been conducted in real life and used an actual ammeter instead of an ideal simulated ammeter, there would have been an internal resistance of the real ammeter, which would have resulted in a non-zero value and would have had an effect on the current readings and the behavior of the circuit. If the experiment was performed on a real life using a real battery and a real capacitor, the capacitor charge would be very short but non-instantaneous rate because the wires used in a real capacitor would have resistance.